I hope everyone can see the screen. So welcome all to this webinar and very crucial topic, and that is called the periodic classification of elements. Okay. So why I have chosen this topic, because this is one of the topic we studied from the 9th standard, even 8th and till 12th standard is really needed. Okay. So what is the periodic classification under this topic? The periodic classification of the elements. So this classification of the elements is arranging the elements in this periodic table. Why? Because if we know, it's very easy. It's very easy to distinguish the items from one another. Example, I'll take one example. It is easy to distinguish the items from one another by sorting them or by arranging them, okay, on the some basis, right? So if you enter into the malls also, all the small kids, ladies, gents, when they enter into the malls and in the shop, we always get the things sorted off, okay, and in their respective places, right? So in shop, if the kids want something, they have to go in the respective section. So kids wear can bought from the section which cannot from the other section. Okay. So the grocery shops also, the shopkeepers also, they align the items in a systematic way so they can find out within a second what the people ask for the thing. Okay. So here also the scientists, so many scientists came and they arranged the elements on the basis of the physical properties. Okay, on the properties. So there are all total 92 well-known naturally occurring elements. Out of that, we have 70 are the metals and the 20 are the non-metals. Okay, so in this, the arranging of the elements, now come to the PPT. If you can see the arranging of the elements into the different groups. Okay, so groups means up to down. Okay. So that is called the groups. And if we are talking about the periods, that is from left to right. Okay. So just now I said the 7 out of 92, the 70 will becomes under from the metals and the rest of the 22 or the 20 are the non-metals. So here the classification on the basis of the elements arranged in the periodic table, that is the similar properties of the element. Okay. If we put in the first group, it means they're having a similar properties. Okay. And classification of the elements in the groups as well as the periodic table. So now earlier it was 92. Now the latest is total 114 different elements known so far. Okay. So the early attempt, if you know about the elements under the category, so we have so many scientists. Okay, so the earliest attempt to classify element was grouping, known for the element about only 30 elements, and that is in the form of two groups. One is the metals and the one is the non-metals. So the defect in this classification, when they arranged these 30 elements, defects of the classification was that it had no place for the metalloids. So we all know we have one more category under the periodic table that is known as the metalloids, and the metalloids is nothing but is the property having both simultaneously the metal and the non-metal, the elements which are having the properties of metals and the non-metals, that is known as the metalloids. Okay, and it's discovered later. Okay. Then the first scientist came, and his name is dominant scientist. What he said, in his law, we call that dominance triads. What is that in this? He arranged the atomic number. He arranged the elements in the increasing order of the atomic mass. He focused only on the mass. What is mass? What is the mass? Mass means if you know the atomic number is equal to the number of electron and number of proton. Whatever the number of proton is equal to, number of electron is equal to atomic number. But the atomic mass is the number of proton plus neutron is equal to atomic mass. Atomic mass is totally depends on the nucleus, means the mass, whatever the proton and neutron present in the nucleus, the atomic mass is totally depends on that mass. So in E strats, what he said, the atomic mass of the middle elements was approximately equal to the average atomic mass of the other two elements. What he said? He said, whatever, if you can see in the table, the first column, lithium, Li, sodium, Na, and the potassium. What he said, whatever the lithium atomic mass, that is 6.9, and the potassium 39.9, if we do the total of 6.9 and 13.9 and divided by 2, we'll get the middle one, that is sodium. So if you can do the addition, 39 plus 6.9 and divided by 2, it approx 23. 22.95 will get. So the average atomic mass of the first and the third element will get the sodium. So he explained in that way. But the defect of this classification or this arrangement of the element is known, is not could be the correct, because one period is okay. Okay, one group is okay, but second group is not possible. See, in the first group, lithium, sodium, potassium. Okay, after that, the strontium, scandium, and all is not possible and not follow this rule. Okay, so that is the defect in this classification. So in the second group, the calcium, strontium, barium is there. So it's showing the 88.7. Not exactly. Okay, that is why this arrangement people rejected. Now the next scientist came. I am just talking about how the arrangement of the element in the periodic table, how the arrangement start. Okay, so the next scientist, his name is the Newlands. He explained the element or arranged the elements on the basis of the octet. What he explained? On the basis of octet. I just inform you people, the octet means 8, means the 8 electron, or in the other word we can say the stability. Stability is always depends on the number of shells. If we discuss about the shells, that is in the next lecture. Now we are just giving the important point, because I already told you the periodic classification of the element started from the 9 till 12. It means so many topics in that. So I am starting from the beginning. So it will be very, very good and very, very valuable for you people to understand from the beginning. So clear the basic. First important thing is clear the basic, then only you can understand the higher things, okay, or higher the topics. So here, Newlands classified the elements in the increasing order of their atomic mass. So what he arranged, he started from the hydrogen. Hydrogen atomic mass is 1, lithium is 3. So what he said, in this hydrogen, helium, and lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Okay, so he is explaining on the basis of increasing atomic mass. When he arranged, what he found that when the elements were arranged in the increasing order of their atomic mass into octave, there was similarity of the properties every 8th element. Every 8th element. See, hydrogen 1, 2, 3, 4, 5, 6, 7 means still oxygen. The first line is 7, and fluorine is come to the 8. So the every 8th element it should be the same. How same? I'll just tell you. See, the fluorine is the in the outermost shell having 7 electron. Okay, so in this they find out the correct thing and explain about the lithium, beryllium, boron, carbon, nitrogen, oxygen. And after that, when come to the fluorine, so what he got, the hydrogen also going to need 1 electron, and chlorine also need 1 electron. So hydrogen sometime, if the hydrogen going to gain, because hydrogen having 1 electron, needed 1 electron for the octet. Here I am talking about the octaves, means the stability. So hydrogen, chlorine, and whatever the bromine and all that is all the same. So the every 8 elements with the similar properties, because the hydrogen, fluorine, chlorine, all they needed a 3 1 electron, so they're having a minus charge. Okay,
Sir,
but
Bashir sir?
yes, yes, who is
Sorry
this?
for interrupting, sir.
Yeah,
This
yeah,
is Madhavan.
yeah,
Sir,
Madhur.
actually, I think your screen is not sharing. Like, you are in full screen, right, sir?
Yeah, I'm in full screen.
Yeah, sir. The thing is, we can able to see the main page only. So just go again and share your entire screen, sir. So that will be
One
good.
minute, 1 minute. Please let me know.
Yeah.
Now you can see the screen.
Wait, sir. It is loading. Yeah. Now you can. I think it is.
Okay, it means when I'm doing the large screen, you're
Yeah.
not able
Just.
to see it,
Yeah. Sorry.
I think. Now you can see or not?
Wait, sir. No, sir. I cannot.
No.
No.
So it means I'll go with the small screen better.
Yeah, sir. Sure.
The small screen is also visible, right?
Yeah, sir. It is also possible. You just go.
You can
Sir.
see this.
Yeah, sir. Yeah, we can see this.
Oh, fine.
Yeah. Thank you.
Okay, sorry. Actually, I don't know about that. Just now, Madhavan informed. Thank you so much, Madhavan. I
Yeah,
thought
sir.
everyone can see. Okay, so you can see the screen. I'm talking about the new lines octaves. Okay, so in this new line octaves, I told you what he explained. He explained the arrangement of the element. What he arranged, the element arrangement on the basis of the octaves. So whatever, if you can see the first line, hydrogen, lithium, beryllium, boron, carbon, nitrogen, and oxygen, and that is till oxygen is 7th element. Okay, when come to the 8th element, fluorine. So what he said, he arranged in that way, every 8th element is similar properties to the first to the 8th. And if you can see, the hydrogen is similar to the fluorine, fluorine is similar to the chlorine, chlorine is similar to the bromine. So you can see this, because why they are similar, in that outermost shell they have 7 electrons, or you can say they all the element need 1 electron, they get the minus charge for the octet or the stability. Clear? So why the people rejected this, I'll tell you. The defect in this classification was all the known element. I request, please mute. Who is this? Thank you. So the defect in this classification was all the known elements and the elements discovered later could not be correctly arranged. Understand? Some elements arranged after the new lines tracks. So that elements, if we want to put in between, that is not suitable in the octave law. So that is why people reject this. Example, if you can see in the first column, this one, cobalt and nickel. Cobalt and nickel is should be in between the chlorine and bromine, but because of this octave or new lines octave is not showing the same. Like cobalt and nickel, because they have showing the different properties, because they need some different elements of electron. So in comparison to the fluorine, chlorine, and bromine, they are different. So that's what this law is also rejected. Okay, now the next one, next law, or the next another scientist, his name is Mendeleev's law, and he is one of the scientists. He explained each and every element in a proper way and in a similar properties, and he put the gap when he give the arrangement of the element. That time he put the gap because he know in the future if someone discover the element, so they can put in between if they belong to this property. Clear? So in this Mendeleev's periodic law, what he states, the properties of the elements are the periodic function of the atomic mass function. Okay, so you can see hydrogen on the first, lithium, sodium, potassium, carbon, rubidium, like that he can fit, and whatever the elements is not suited, he didn't put, he put the gap. Okay, so what is there in the Mendeleev's periodic law? Mendeleev periodic law classified. Sujita, please mute. I request you. Sujita, you can hear me? Madhavan, please ask her to mute. Thank you, Sujita. Okay, so what he explained in Mendeleev. See, the Mendeleev classified the elements in the increasing order of their atomic mass and the similarities in their properties. Okay, I request you again, all the students who join and the parents, whatever the faculty, if any doubt, any query, you can stop me and clear your doubt, and or you can note it down in your notebook. End of the lecture or end of the webinar, you can clear your doubt. Important thing is not to attend the lecture or listening the lecture. Important thing is that you have to understand 101% with concept. Okay, that is my priority always. So the similarities, atomic masses and the similarities in the properties. So the formula of the oxides and hydrides. Now you are thinking, what is oxide, what is hydride? See, if any element join or react with the hydrogen, form hydrides. If any element join with the oxygen, known as oxide. Okay, like sodium with oxygen, sodium oxide. Okay, lithium with oxygen. Yes, Vignesh. Yeah, tell me.
No, sir, nothing, sir.
Nothing. Okay, fine. So the formula of the oxides and the hydrides formed by the element was also the basis of the classification of the elements. Okay. So the Mendeleev periodic table has 6 horizontal rows called the periods, means left to right. Horizontal means left to right. I hope you people understand. Periods. And 8 vertical, that is up to down, in the form of groups. But later, so many groups came. That is, total is 18 groups. But I am talking about that period when the Mendeleev's arrangement. And we have now 7 periods. So the groups now 1 to 7 had 2 subgroup in the form of A and B group. So the group A and had 3 groups. So in that elements we have the similar properties at the place, and some places are vacant in the table to accommodate the elements to be discovered in the future. What Mendeleev did, but Newlands is Dominor is he didn't left any space. That's why his classification, his law or his arrangement is rejected. Now, what are the merits things in the periodic table, Mendeleev's periodic table? See, what are the good things? First point, elements were classified on the more fundamental basis of the atomic mass and properties. This is a good thing for the Mendeleev. Second, spaces for the left for the future discovered element. Okay. Third point, it could predict that the properties of the element which help in the discovery of the future. Okay, or whatever he discovered on the basis of the properties they can put. And the last, what is the important thing, what is the good thing under the Mendeleev? That is the inert gas element. Inert gas element discovered later. Also, we can place anywhere. So we could be placed in a separate group without disturbing the element table. So he didn't put any noble gas in between the other element. So he put the separate table or separate group for the, so whatever the noble gas came, like helium, neon, argon, krypton, xenon, radon, these are all the noble gas. So you can see in the 18 group, last right side. Okay, but with good things, with bad things is also there in all, whether it's the human beings, whether the things. So no one is 100% perfect. Okay, so here for the Mendeleev's also some defects is there. So what are the defects? I'll just tell you. Some elements are not arranged in the increasing order of the atomic mass, like cobalt is placed before nickel. Before nickel, it should be the after nickel, because cobalt atomic mass is more in compared to the nickel. This is the first defect. And tellurium is also put is placed before I. It should be the after I. So these are the first defect. Second, position of the hydrogen is not clear. Position of the hydrogen is not clear because the position having hydrogen having the two similar properties. And what he said is it belong to the first group because hydrogen can donate one electron and become H plus. So the first group like hydrogen, sodium, potassium, these are belong to the first group. They are donating element and getting the plus charge. But the hydrogen having the similar properties as per the new lines, you can see need one electron for the octet. That is also the properties like halogen. And having the properties of the noble gas, because when the hydrogen gain one electron in the first shell having two electron, it means it's stable, it comes under the noble gas. So hydrogen is one of the element having up so many properties similar to the different groups. Is belong similar to the first group because hydrogen can donate and get positive charge, and having the halogen properties get one electron and get minus charge, and when they gain two electrons become stable and belong to the 18 group called noble gas. That is why he's not explain or not clear with the position of the hydrogen, whether it comes under metal or comes under the non-metal. And the last, the position of the isotopes of the element is not clear. What is isotopes? I'll just clear here itself what is isotopes, otherwise you people confused. Isotopes means the element which having the same atomic number but different atomic mass. Okay, same atomic number means element should be same, but only the changing in the atomic mass because changing in the neutron. Clear everyone? So that isotopes element, because we have so many isotopes like nitrogen. Nitrogen having 714, 715 and 716, three isotopes. But in the periodic table, if you can see, only one nitrogen element is there, that is 714, that is the main. Other two is the isotopes of the 714, so that is not there. That is also the defect. Okay, so these are the defects and these are the merits of the periodic table. Now this is the modern periodic table law is totally prepared, and whatever the empty spaces or the vacant, what Mendeleev did, that is also done with the other future scientists who came and discovered the elements. Okay, so if you can see the modern periodic table, in this the properties of the elements are the periodic function of the atomic numbers. You just see the periods is this one: 1, 2, 3, 4, 5, 6, 7, and groups 1, 2, 3, 4, 5, 6 till 18. 18 groups in the periodic table, and below that you can see the two periods. Okay, that is comes under the different block. We can put in a different, that is having a some different properties because they are comes under the F block that we'll discuss later. Okay, so these are the important property or the arrangement of the and final arrangement what we people are studying nowadays. This is called the not Mendeleev periodic table. We call this modern periodic law of or periodic table. Why modern? Because everything is added. There is no other elements going to discover. If going to discover, they are going to shift and they are going to place the some other place. This is the periodic table of the elements. If you can see, hydrogen, we can put the green color. Why? Because having a different properties. Okay, under the different properties, if you can see, I told you already, hydrogen having the property of this first group, hydrogen having the property of the 9th, this one 17th group halogen, and halogen having the properties of the noble gas. Okay, so these are the important points. And this is also the periodic table, that is this explain about the Central Washington University. What he did, if you can find out the difference, the hydrogen is attached to this group lithium, but later now if you can see, the hydrogen is little bit separate from the lithium and put it on the first group above. That they are showing it's not attached to the lithium, It's separate place for the hydrogen because of the different properties and join. So that is also the important points related to this. Now, what are the modern periodic table properties after filling all the vacant, all the space? See, in the modern periodic table, elements are arranged in the increasing order of their atomic numbers in the form of table having 7 horizontal rows of elements called periods and 18 vertical rows of the elements called group. In the periods, there are 7 periods of the elements. First period has 2 elements, hydrogen and helium. You can see here, this one, okay, this one, first and right side helium, top one, the first period. And second one, if you can see, second periods having 8 elements. You can see lithium, beryllium, 2, then boron, carbon, nitrogen, oxygen, fluorine, neon. Total 8 elements in the second period. And in the third period, if you can see, we have again the 8th element, that is sodium to argon. Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. Okay. And the fourth period, we have 18. Then fifth is 18. Sixth is 32. Seventh is 28. So now you are little bit, you got the idea. See, the first period is 2, second period is 8, third period is 8, fourth period is 18, then 18, then 32 and 28. When you are writing the shells, that time also you are writing 2, 8, 8, 18, 32. That is come from the periodic table arrangement. Means the element arranged in that way, you are arranging the elements, the shells also the same. In the KLMN, what you are writing? 2 in the first shell, second shell 8, third shell 8, fourth shell 18, then fifth shell 32. Like that you are writing. So that method came from this. From the horizontal, if we have said the periods, 1 is 2 element, that is first shell. Periods 2, 8 element, that is the second shell. Periods 3, the 8 elements, the third shell. Period 4, 18 elements, the fourth shell, and fifth shell. Like that you are arranged. So that is the way how you are going to link your concept. So you can understand, if you know the number of shells, how many electrons. So if someone asks in fourth period, how many elements? So on the basis of shells, you can explain and you can tell that is only 18 elements. You understand my point, everyone? Now come to the 7th period, 28 element, and we have incomplete period. You can see the last one is incomplete. 110, 111, 14. Now the 114 is there, but it's not there in this periodic table. So 14th element of each of the 6th and 7th periods are placed separately at the bottom of the table. 14th element, each of the 6th and 7th. So this is my 6th. 55. You can see here 1, 2, 3, 4, 5, 6, 6 and 7. Whatever the 6th and 7th, the extra element we put down in the form of cerium and thorium. Okay. Fine. So yes, who is this? You want to ask something, Mohammed? Please mute. Mohammed Shaban, please mute. Thank you. So these 14 elements we called lanthanide and the actinides. Those who are in 9th, 10th or 11th, they don't know about this because this is the 12th portion of the D and F block, lanthanide and actinide. So you just remember till here, what is lanthanide? That is the 6th and 7th period of the periodic table. We place the extra element down in the form of lanthanoid and the actinoids. period elements series. Okay, this is about the periods. Now come to the groups. See, we have how many groups? 18 group. How many groups? 18 group. Please see the group. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, then 13, 14, 15, 16, 17, 18. Okay. So we have 18 groups and divided into 9 main groups. First, second, third, fourth, fifth, sixth, and 0 groups. Okay. So the A subgroup we call the normal elements. Okay. And the B subgroup we call the transition elements. And the lanthanoids and actinoid that is below the periodic table that we call the inner transition element. Okay. And the group 1 elements we call alkali metal. Left hand side, first one, alkali metal. Left hand side, second group, that is known as the alkaline earth metal. And the 17 group means the second last, in the right side, second group, that is known as the halogen groups. Okay, because they are also called the electronegative element. And the last 18 group called the 0 group means they are fully satisfied. They don't want anyone, and they even not entertain anyone because they are fully satisfied with the full octet. So in a group of all the elements having the same number of the valence electron, we put into the group 1 elements, that is known as the 1 valence electron group. So group 2 having the 2 valence, group 3 3 valence, like that. On the basis of that, the valence electron, on the basis of the valence. If we are talking about the 17 group, first element is the valency is -1. The second group of the 17 group is also the same -1. Doesn't matter the atomic number is more, but the valence electron should be the same. Clear? So in the periods, all the elements contain the same number of shells also. Okay. Periods means left to right. If the hydrogen is, if the lithium is 2, so the next is, after lithium, which element? Beryllium. Beryllium also the 2 shells. Means while going left to right, there is no increasement or in the shells. But when you're coming down the group, it's increase in the shells. Now, I told about the valence electron. What is valence electron? Valence electron means how much electron present in the last shell. Example, lithium. Lithium atomic number is 3. So 2, 1 means first shell we cannot put more than 2. So that is only 2. So rest of the element, how many elements left? Out of 3, 1. So we are going to put into the second shell 1. So what is the valence electron of the lithium? That is 1. Okay. So the valency of the lithium, see this one. Lithium atomic number is 3, 2, 1. So valence electron is 1. So how many shells? Only 2. Because in first shell 2 electron, second shell 1 electron. Okay. If we are talking about the same in the group, this is all I'm talking about the periods. Beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8. This is all the different. See, the shells all in the same, but only changing in the valence electron. Lithium having 1, beryllium 2, boron 3, carbon 4, nitrogen 5. So these are the changes in the valence electron, but the shell is still same. 2, 2, 2, 2, 2, 2, all. So in the group, if you can see, hydrogen electron is 1. How many shell? 1. But lithium shell is electron is 3. How many shell? 2. Sodium electron is 11. So 2, 8, 1. How many shell? 3. So what is the conclusion? In periods, the same in the shells, but in the group, increase in the shells. Clear? This is the conclusion under valence electron. Now we are going to discuss about valency. Valence electron, valency is totally depends on the valence electron. If you don't know the valence electron, you are not able to calculate how much valency of this element. Example, the lithium. Lithium valence electron is 1. So always remember, if you have the valence electron, that is 1, 2, and 3. Means in the last shell, if you have 1 electron, 2 electron, and 3 electron, they can lose the electron. They can lose the electron. But if they have 5, if they have 6, if they have 7, 8 means it's totally octet. Okay. If they have 5, 6, 7 in the last shell, that time instead of losing 5, better to gain 3. Understand my point? Understand my point? Means if you example the lithium in the outermost shell is 1 electron. So what is the easiest way? Taking 7 or losing 1? Better is lose 1 and be satisfied with the 1 shell. So same thing is there in the nitrogen having 5 electron in the valence electron. 5 electron in the valence electron, it means they need 3. So instead of losing higher number, better to receive 3 and be satisfied. So 1, 2, 3 going to lose, they get the positive charge. Means losing 1 electron plus 1, losing 2 electron plus 2, losing 3 electron plus 3. Now come to the 5 electron. If they have 5 valence electron, so you need 3. Means you're receiving, that is known as the minus charge. So receiving 3 minus, receiving 2 minus 2, receiving 1 minus 1. This is the valency. So if someone asks, what is the valency of sodium? Now you are thinking atomic number. Atomic number of sodium is 11. Then you divide into the shell 2, 8, 1. It means outermost shell, the valence electron is 1. 1 is easy to leave. Better to take 7. So the valency is plus 1. Means you can do like this, the calculation. Example, boron. Boron atomic number is 5, 2, 3. So instead of taking 5, better to lose 3. Losing means plus 3. Clear? So this is all about the valence electron. So I hope everyone understand. But valence electron in the periods is changing. Shells is same. In periods, shells is same, but the valency is different. Valence electron is different. But in the group, the shells is increasing, changing, variation in the shells. But the valence electron is same, valency is same. This is the properties in the valency. Now, what is the atomic size? See, the atomic size is totally depends on the shells. If the shells is increasing, the atomic size is increasing. If the shells is same, no size increasing. I already told you in the periods, left to right, no increasing in the shells. It means radius of the shell is also same. Radius of the shell is also same. So in that radius is also same means the periods is same shell. So radius is same. The atomic size is the same. But in the group, shells is increasing. Radius is increasing from the center of the nucleus. It means the size is also increasing. So what is the conclusion? When the periods having the same atomic size while the group is increasing the size while going down the group. Okay, this is the increasing of the, you can see atomic radius is same. Boron, carbon, nitrogen, oxygen. Okay, lithium, beryllium. But if you can see the group, boron circle is very small. Orange circle, please see. Boron is small. Then aluminum increase one shell is big. Then gallium little bit big, and indium is little big. You can see the first group. Lithium is 152. Sodium 186. Potassium 186. So lithium is 2 shells, sodium is 3, potassium is 4, rubidium is 5, and cesium is 6. So as per the 6, the circle is big, means the outermost shell. So that is why the increasing in the size. But in this one, you can see there is no increasement in the size in period because the size is same. Only the number of atomic number is increasing. Yeah, one thing I didn't explain, you people also not ask, sir, in the outermost shell, all the valence electron, we have 1, 2, 3, you said, uh, losing the electron and getting plus. And when the outermost shell having 5, 6, 7, you are going to lose and getting minus charge. What about 4? The element which having 4 electron in the outermost shell, because in the outermost shell as a valence electron also 4, and they needed also 4. In that way, what they will do? So they cannot lose and they cannot gain. They will always share. Okay. So whatever the carbon family, they always share the electron. They form methane, they form ethane, they form propane. All the alkanes they form with the hydrogen, they share the electron of hydrogen. Clear? So the in the periods, the metallic properties of the element decreases from left to right. So metallic properties also decreases. I told you the metals form the period. Left side of the periodic table is called the metals. The right side is all the non-metals, and in between of the periodic table known as the metalloids. So you can say in one sentence, while going from left to right is increasing or changing the properties of the metallic properties. Because if you start from the lithium is metals, then beryllium is metals, then carbon is again metal, but nitrogen again gas. And in between we have metalloids, that is in down. So metals to the non-metal, non-metal belong to the gas. So they change the properties of the metals. So sodium, magnesium, aluminum, left to right is metals. Then in between silicon, that is non-metal because they have both the properties, metals as well as the non-metals. Then phosphorus, sulfur, chlorine, and argon, these are all the non-metals. You can see here. So this is the properties. So you can see the metallic property decreases. Or you can write the another word, non-metallic properties is increases. Okay, you can be whatever you want, you can write. This is about the period. Now come to the group. In the group, metallic properties is increasing always. If it is non-metals, example nitrogen family having a first one is the non-metals, gas. Then after that, metalloids, then non-metals. Sorry, metals. So from the non-metals to metalloids, then metals. So in the periods, the conclusion is periods increasing the non-metallic characteristics, or you can remember in that way, in periods left to right is decreasing the metallic properties, and up to down, means in group, is increasing the metallic properties. That is the conclusion. Don't be confused yourself. Okay, so these are the important points related to the, this is the metallic properties. Okay, now come to the non-metallic properties. See, the non-metallic properties, just do the ulta of the metallic properties. That is, convert into the non-metallic, means you just write in front of decreasing, right? Increasing. Non-metallic property increasing, I told you. If someone asks, what is the non-metallic properties? So non-metallic properties is increasing in the period and decreasing in the group. This is all about the general information on the basis of the 9th level. Okay, so 10th level, we have to go under that and we have to explain what is valence electron, how to form the structure in the form of shells, what is the electronic configuration, what is KLM, and how to draw the structure, dot structure, that we will discuss in the webinar, second series of the webinar. In that, I'll come with your new topic that is on the 10th level. I think everyone understands this is one of the basic. If you understand this, it will be very easy to understand the next series of this webinar or this topic, the periodic classification of elements. I hope you people understand, and you just, if anyone have the query, you can ask your doubt. I'll explain with sharing of screen. So if I needed to explain with writing, I'll explain with write. So please, whatever, if you are leaving the meeting, so you have to be clear this level. Because the next series, when it will be, the coordinator will be arranged, that will be easy for you. Understand? So now the question time, you have 10 minutes, you can ask. 5 minutes, you can ask your question if you have any doubt. Yeah, thank you so much, Madhavan. From my side is, I'm doing the handover to you. You ask the audience or the students or the parents, anyone have the query, you can ask and clear your doubt. I'm here. Thank you so much.